Last class, we talked about the basic introduction to transformer. In that class, I told you the definition of transformer, where I said the transformer is a device that either step up or step down an AC voltage source. Now we talked about some classes of transformer. We understood that we have two basic types of transformer. The first one was the step up transformer, and the second one was the step down transformer. But in today's class, we'll be talking about the working principle of the transformer. The working principle of the transformer. Now, how does the transformer work? Last class, we were able to identify the primary side of the transformer and the secondary side of the transformer. And I told you that for you to identify your primary side of your transformer is look at your transformer. That side that is connected to the AC source is your your primary side, while the side connected to your load is your secondary side. So if you look at this transformer, we can see that in this transformer, the first thing you notice is look at your windings. You can see that this side of the windings, it is very small, while this other side, the windings are they are more. So which transformer is this? Is this a step up transformer or a step down transformer? Now the first thing that should come to your mind is your secondary windings. Your secondary windings, they are greater than your primary windings. So this is a step up transformer. Now for you to identify your AC side of the transformer and the other side of the transformer is, we have already identified this side to be our secondary side of our transformer. So this secondary side is always connected to our load, while this other side is connected to our AC source. So you've been able to identify that this is a step up transformer. This is the step up transformer. Now, what should come to your mind is, how does the transformer work? That's why we want to talk about the working principle of the transformer. Now, current enters the primary side of the transformer, and voltage is being induced in the secondary side of the transformer. So we know that this side is the secondary, while this side is called the primary. And I told you current enters in the primary, and voltage is induced in the secondary. Now, how does that work? Now, when current enters the primary side of your transformer, the windings of the transformer starts moving. They start rotating. Now, when that winding starts rotating, that causes it causes the windings to generate what is called the magnetic field. So magnetic field is being generated from the primary side of the transformer. Now, when this magnetic field is being generated, the magnetic field passes through this ferromagnetic material. So now we've understood that this is a ferromagnetic material, and magnetic field is being generated in your primary side of your transformer. So this is a ferromagnetic material. Now, your magnetic field passes through this ferromagnetic material down to your secondary side of your transformer, where voltage is being induced. Now, this area or this region in which your magnetic field flows through to your secondary transformer is what we call the flux. So you can call it magnetic flux, or you can call it magnetic density. So the area in which your magnetic field flows through to your secondary side of your transformer is called your magnetic flux, or your magnetic density. So in essence, current passes through your primary, voltage is being induced in your secondary, and what flows through your ferromagnetic material, what flows here is your magnetic field. So your magnetic field is being generated in your primary, and your secondary voltage is being induced in this secondary. So take this down. The working principle of the transformer shows us that current passes through what? The primary side of your transformer, and voltage is being induced in your what? Your secondary side of your transformer. Now, when current passes through your primary coils, magnetic field is being generated. When current passes through your primary coils, magnetic field is being generated. Magnetic field flows through a region called your ferromagnetic material. Your magnetic field flows through a region called your ferromagnetic material down to your secondary side of the transformer, where voltage is being what? Induced. Now, the region where your magnetic field flows through is what we call the magnetic flux, or what? Magnetic density. So this region through which your magnetic field flows through to the secondary is called your what? Your magnetic density, or your what? Your magnetic flux. Now take this down. In the absence of losses, your power input will be the same as your power output. In the absence of losses, your power input will be the same as your power output. What do I mean? I mean, when you ignore losses, your power in the what? Your primary will be the same as the power in your what? Secondary. Now let's take an example. Let's say we have the number of turns here for the primary. These are primary side. So we have the number of turns here to be what? 100. And we have the number of turns here to be what? 1000. Why are we having 100 here? And why are we having 1000? Why is this value greater than this value? Because of the what? The windings, or the what? The coils. So we are saying that the number of coils, or the number of windings at your secondary is what? 1000. And that in your primary is what? 100. Now note, when you move from left to right, when you move from primary to secondary, your number of turns increases. When you move from primary to secondary, your number of turns increases. Also, when you move from primary to secondary, voltage what? Increases. So voltage here increases as you move from this, the left side, to the what? To the right side. But when we talk about current, when we move from primary to what? Secondary, current what? Reduces. So what do we mean? It simply means that as we move from primary to secondary, your number of turns increases. As we move from primary to secondary, voltage what? Increases, but current what? Reduces. Now let's take this example. Here they said what? Your number of turns, or your number of coils for your primary is what? 100. And your number of secondary is what? 1000. What if they give us the voltage here? Voltage of the what? Of the primary to be 12 volts. What will be the voltage here? But we already know that as we move from primary to secondary, voltage what? Increases. So the first thing that should come to your mind is, what is the ratio between your secondary and your what? Your primary. When we talk about ratio, it simply means divide this from this. So if you do that, if you do 100 ratio what? 1000, it simply gives you what? 10. So what do? Since we are talking about increase in voltage as we move from primary to secondary, it simply means take this voltage that is given here, multiply it with this. What will you have? So if you do 12 times 120, you simply have your Vs to be voltage in the secondary to be what? 120 volts. What if you are giving the current here? They say the current here is what? Current in the primary. They say the current here is 10 amps. What will be the current for your what? Your secondary side of your transformer. Now, come back to what I gave you. I gave you number of turns as you move from primary to secondary increases. voltage what increases, but current what reduces. So when we are talking about reduction in current, it means divide what you are giving with the ratio that you got. So it simply means for you to get your IS, which is current in the secondary, it simply means this 10 amps divided by your 10 as you got as the ratio. So if you do that, you simply have what IS to be what 1 amp. So here you are getting your what your current in your secondary, which is IS to be what 1 amp. But we know that when we talk about power simply means current times what voltage. That is power. So to get our power input or your power output, we initially know that power is equal to what current multiplied by what voltage. So your P here is simply what IP. Now, but we want to get the power input here, and we also want to get the power output, which is the power at your secondary, which is this, and the power at your what primary. So for you to get your power input, which is represented by what PI subscript N, it's simply what is your current? What is your current here? 10. What is the voltage? 12. So it simply means 10 times 12 is equal to what? 120 volts. Now let's calculate the power output. We know that power output is equal to current times what? Voltage. We know that our current is what? 1. Our voltage is what? What's our voltage? 120. So your power output is simply what? 120 watts. This is also watts. So you succeeded in calculating your what? Your power input and your what? Power output. Now look at your power input. You have 120 watts, and your power output is what? 120 watts. That is how the transformer works when we ignore losses. But if you consider losses, if losses are being considered, then it will not be the same, because those losses will try to reduce these values. We've been talking about losses. We've been talking about ignoring losses, and we've been talking about considering losses. And we said when you ignore losses, your power input will be equal to your what? Your power output. But when those losses are being considered, then you won't have the same value. Your input will not be the same as your output. Now, what are those losses? When we talk of transformer, what are the losses we see in transformer? Now, the first one is called your copper loss. The first one is called your copper loss, while your second one is called your what? Iron loss. So take down types of losses. Now, when we talk of types of losses in transformer, I said the first one is what? Copper loss. While the second one is called the what? Iron loss. So these are the two major types of losses we have in what? Transformer. The first one, which we are going to talk about, is what? The copper loss. While the second one is what? Your iron loss. When we talk about the copper loss, come to your transformer. Ask yourself, where can we see this copper? Now look at your primary side of the transformer and look at the secondary side of the transformer. Now this side, I told you, the primary side consists of what? Coils. And those coils are also known as what? Windings. Now these coils are made of what? Copper. So if you are talking about the losses in your transformer, then you are considering both your what? Your primary and your secondary. So you are talking about the copper loss in your primary, and you are talking about what? The copper loss in your what? Your secondary. So for you to get the copper loss for this transformer, the copper loss is simply denoted with this equation. Now for your copper loss, if you are asked to calculate for your copper loss in this transformer, what you do is calculate for this loss in your primary and also calculate for the loss in your secondary. So to do that, your equation is given by what? For your primary, you simply have what? I1 square R1. While for your secondary, you simply have what? I2 square R2. So total, for you to get the total copper loss. So the total copper loss will simply be what? I square R1 plus what? I square R2. So this is the equation you use to calculate for your what? Your total copper loss. The next type of loss we are seeing is what? Iron loss. Now, when we talk about the iron loss, what should come to your mind? Come back to your transformer. Where can we see the what? The iron. Now, we've already talked about this primary and the secondary. And I told you, these ones, they are made of what? Copper. That's why we are talking about what? The copper loss. But the next thing we are seeing is what? Iron loss. Now, come back to your transformer. What can you see in your transformer that is made up of iron? You can see this coverage here, this material here. We can see this material. And we said this material is a what? A ferromagnetic material. Now when we talk of ferro, we mean what? Iron. So if we are calculating for the loss, for iron loss, we are considering this part here. That is why it's called what? Your iron loss. Now your iron loss is denoted by what? PC. It's denoted by P subscript what? C. So if you see this symbol here, if you see this symbol as this closure, then you know that what? We are asked to calculate for what? Your iron loss. Take this down. Note, your iron loss is always a constant. Note, your iron loss is always a constant. Now, it simply means your iron loss will always be given to you in your question. So when you are calculating for other losses, meaning your iron loss will always be what? A constant. It will always be given. So look forward for your what? Your iron loss first. Bring out your iron loss from that equation before you now what? Calculate for your what? Your copper loss. And I told you to calculate for your copper loss. You use this what? Formula. You first get your what? Your primary. So this one here is your what? Your primary. Then you get for your what? Secondary. After getting for both of them, what do? You add both of them together. You now get your what? Your total copper loss for that transformer. Now the next thing that should come to your mind is, what if these losses are being considered? How can we get the power input and how can we get the power output? Now let's go into how we can calculate for the power input when our losses are being considered. Now let's come back to transformer. So when we are asked to calculate for your input power, your input power is simply what? The output power plus your what? Your losses. Now what are these losses? These losses are those ones which we call the iron loss and the what? The copper loss. But we are asked to calculate for your what? Your input power. And we said your input power is simply what? Your output power plus your what? Your losses. We already know that your what? Your losses are the what? The iron loss and the copper loss. Now what should come to your mind is, what is now this output power? If we said input power is equal to output power plus losses. Now the output power, we should know that the output power consists of what we call the packing factor. Packing factor. Now this packing factor is denoted by what? PF. Packing factor. Now what is the packing factor? The packing factor helps to measure what? The effectiveness of the coil in the secondary side of your transformer. So that packing factor is there to calculate, it just helps to measure the effectiveness of how the coil or how the windings of the secondary transformer is. So when you are calculating for the output, you are adding what? That packing factor. What if in a case where you are asked to calculate for efficiency or efficiency based on either your input power or your output power. Now take this down. Your efficiency is simply what? Output power divided by what? Your input power. So this equation is applicable when you are asked to calculate for your efficiency. Sometimes you can still add times 100 here, so you can get your answer in percentage. But if you are not asked to leave your answer in percentage, then you ignore this for 100 here. You understand? So now, for you to calculate for efficiency based on your input power, what do? It simply means anywhere you see your input power, you substitute your what? Output power plus losses. So efficiency based on your input power. Efficiency based on your input power. It means come back to your efficiency, which is what? Output power divided by input power. So now, anywhere you are seeing input power, what are we putting? Output power plus losses. So let's substitute this into this equation. Now this will give us what? Output power divided by, what's our input power? Our input power is simply what? Output power plus what? Losses. So you are simply having your output power divided by what? Output power plus losses. So this is how you can calculate for your efficiency based on your what? Your input power. But look at this output power. We know that when we are talking about power means what? IV. That is what? Current times what? Voltage. So this output power here, it's simply what? The output power we have here can simply be written as, we are talking about current in the what? Secondary times what? Voltage in the what? Secondary. And when we talk about output power, I talked about what? Packing factor. So this is multiplied by what? Our packing factor, which is PF. So this is divided by what? The same thing we have here. So if you do that, we simply have what? I2 multiplied by what? V2 multiplied by what? Our packing factor. Plus, what is now our losses? Our losses will now be what? PC, which is iron loss, plus I square R, plus what? I square R. This is what? The primary what? Copper loss. And this is what? Your secondary copper loss. So you are multiplying your what? You are adding your what? Your iron loss and your what? Your copper loss. So this equation is applicable when we are asked to calculate for what? Efficiency based on your what? Your input power. So we've succeeded in calculating for efficiency based on what? Our input power. Let's calculate for efficiency based on output power. So the next one is efficiency based on what? Output power. Now, look at our efficiency formula. We know that our efficiency is equal to what? Output power divided by what? Input power. Now, recall that our input power is equal to what? Output power plus what? Losses. Now, from this place, what are we going to do? What we want to do now is make output power subject of formula from this place. Now, if we make output power there subject of formula, we simply have what? Output power is equal to what? Input power minus what? Losses. So we are having what? Input power, take this one to this other side. Addition, crossing an equality sign, it is what? Subtraction. So this is what minus losses. This is what we have here. So this is what losses. So you substitute this now into your equation when you see what output power. So your efficiency is equal to input power minus what? Losses divided by, what do we have here? Input power. So this is divided by what? Input power. So if you do that, we can still break down this equation. Now breaking down this equation, we can still rewrite this equation to be input power divided by what? Input power minus losses divided by what? Input power. Now, what's the next thing we can do? Look at this. This is input power. This is input power minus losses, and this is what? Input power. So this can what? Scratch this. So if this scratch this, means input power divided by input power. It's simply what? 1 minus losses divided by what? Input power. So we've succeeded in getting the equation for what? Efficiency based on what? Output power. So now if we are asked to calculate for efficiency, we can simply do that by what? Using either this or this formula in calculating for what? Efficiency. So we've succeeded in getting the efficiency of both the outputs and the inputs. So if we are asked to calculate for the efficiency of a transformer based on their input and output, we can do so. Now let's talk about types of transformer. Basically, in this course, we have 3 types of transformer. The first one is what we call the instrument transformer. The second one is called the auto transformer, while the last one is called the what? Tap changing transformer. So you will be hearing what? Instrument transformer, auto transformer, or what? Tap changing transformer. So you should know these various types of transformer. Now let's take it down. I told you we have basically 3 types of transformer. The first one is what we call instrument transformer. Instrument what? Transformer. The second one is what we call the auto transformer. Auto transformer. While the last one, which is the third one, is called the tap changing transformer. Tap changing transformer. Now take down this first one, which is called the instrument transformer. What is the instrument transformer? Now take this down. The instrument transformer are those transformers used to measure electrical quantities such as voltage and current. They are also used to step down current from high to low. So this transformer, the major work of this transformer is to step down current from what? High to what? Low. So the transformers, basically in this instrument transformer, they are what? They step down transformer. Step down transformers. So note that the major work of the instrument transformer is to step down what? High voltage to what? Low voltage. So what type of transformer does that? Is the what? The step down transformer. Now the next one is our what? Auto transformer. What is our auto transformer? Now take this down. They are transformers used to achieve voltage stabilization. So the major work of the auto transformer is what? Stabilization. Stabilization. So if you are asked what type of transformer helps in stabilizing the what? AC current, you simply note it is what? It is the what? Auto transformer. Now the last one which we'll be talking about is what? The tap changing transformer. What is the tap changing transformer? Now the tap changing transformer, they are those transformers that allow what? Voltage to be what? Adjusted. They are those transformers that allow voltage to be what? Adjusted without disconnecting what? The transformer from the what? Circuit. So this transformer, its own part is to what? Adjustment of voltage. Adjustment of what? Adjustment of voltage. That's the major work of the tap changing transformer. So you can see the difference between the instrument transformer, the auto transformer, and the tap changing transformer. Now the instrument transformer, we said the instrument transformer, the major work is to step down what? High voltage. Step down the voltage from what? High to low. While the auto transformer is to what? To achieve what? Stabilization. What about the tap changing transformer? The tap changing transformer, they are those transformers that they are adjustable to what? To voltage.